Okay, today our TEKS are 5.3J. The student is expected to represent division of a unit fraction by a whole number and division of a whole number by a unit fraction, such as 1/3 divided by 7 and 7 divided by 1/3, using objects and pictorial models, including area models. Also, TEK 5.3L, the student is expected to divide whole numbers by unit fractions and unit fractions by whole numbers. Today we're going to solve the word problem. It says, Lucy buys 5 cakes for her party. She knows she needs to be fair and split the cakes equally among her friends. Lucy finds out that if she gives each friend 1/4 of the cakes, they will all receive the same amount. How many friends are at Lucy's party? So if we look at this word problem, we have 5 cakes, and she's splitting them equally among she's giving each of her friends 1/4 of a piece, and we want to find how many friends Lucy has at her party. So our equation today will be 5 divided by 1/4. We're going to solve this equation using linear model with a number line and area model with our graph paper, our grid paper. Some things to look at before we start is that parts of a whole definition, let's just quickly do a quick reminder. If A over B, or A, never say A over B, that's a misconception that you could have. It's A beats, I guess, of a whole indicates that a whole has been partitioned into equal sized parts, and A of those parts are being considered. So today we're dividing 5, our whole number, into 1/4, our unit fraction. A unit fraction is a quantity formed by a part of a whole that has been divided into equal sized parts. So 1B. So we're going to start by using our area model. So our whole is 1, but we have 5 cakes, so we know we have 5 wholes. So for our area model, we need to draw our 5 cakes. So we have 1 cake, 2 cakes, 3 cakes, 4 cakes, and 5 cakes. And from our parts of a whole definition, we know that we are dividing, but our denominator tells us that we want our cakes to be divided into 4 equal sections. So we have 1, 2, 3, 4, 1, 2, 3, 4, 1, 4. So each of these regions is 1/4. A common misconception among students is that this would be 1/4, 2/4, 3/4, and 4/4, but the attribute of area model is area, so each of these is equivalent to 1/4. So our question is asking us how many 1/4 pieces, or 1/4 regions, fit equally into our 5 wholes. So if we look, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we know that 20 equal size areas fit equally, size 1/4 fit equally into our 5 wholes. So 5 divided by 1/4 is equal to 20. So that's our area model. Now let's look at our linear model. So for our linear model, the attribute is length. We have a length of 0 to 5 because we have 5 holes. So each of these big tick marks represents the length. So we have 0, 1, 2, 3, 4, 5. So we have, our hole is 1, but we have 5 holes. So 1, 2, 3, 4, 5. We know that we are looking for 1/4 pieces or 1/4 lengths to fit. Because our attribute is lengths, it's 1/4 lengths to fit equally into our 5. So if we go, these little tick marks will represent the lengths of 1/4. So we have 1/4. Unlike the area model, the linear model is sequential. So it's 1/4, 2/4, 3/4, 4/4, or 1, 5/4, 6/4, 7/4, 8/4, or 2, 3/4, 5/4, excuse me, I said 8/4, so this needs to be 9/4, 10/4, 11/4, 12/4, or 3, 13/4, 14/4, 15/4, 16/4, or 4, 17/4, 18/4, 19/4, 20/4, or 5. So if we look, and we want to find, once again, how many 1/4 lengths fit equally into our 5 holes. So 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4, 9/4, 10/4, 11/4, 12/4, 13/4, 14/4, 15/4, 16/4, 17/4, 18/4, 19/4, 20/4. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we have 20 equal size lengths, size 1/4, that fit into our 5 holes equally. So both the linear model and the area model tell you that if you do 5 divided by 1/4 and you want to know how many 1/4 fit equally into our 5 holes, you get 20 lengths for linear model and 20 areas for area model.